Alright, I guess I'm online again. Good evening. It is Wednesday. I believe I said I was going to go either Tuesday or Wednesday last week, but I forgot what I said, so here we are. I actually went to an event last night for doing, or a C# event for handling, um, doing message buses and things like that. But I just want to point out that I've added some about section and social with YouTube and GitHub links. I'm eventually going to put my code up on GitHub here shortly, as a matter of fact. But it should be underneath the go to repositories, Elastic IRC Bot. So so this video is mostly going to be about me talking about some of the design decisions that I made recently. Last time I talked about how I was getting bored of trying to explain how to do parsing, and I'm sure you guys got bored of trying to listen to me try to do parsing and solving those sort of problems on air. While I didn't fully get through all of that over the weekend, I did get pretty far, at least getting the lexing taken care of. But then I also thought of what I actually want to do with this project, since I've been asked that a few times already. Really what I want to do is I'm doing all this crazy work just so I can kind of look at various commands and that come in through the IRC, and then try to eventually hook that up with Elasticsearch, and then try to set up a setup to where I could just query Elasticsearch, and I can actually get or do some reporting based off of that too. So maybe set up, full text searching or something. I don't know. I don't know what I'm going to do with Elastic just yet, but all I know is for sure is that the eventual goal is to have this IRC bot push data into Elasticsearch, and that's going to require quite a bit more functionality to add here later, since I don't have an HTTP library going on in the code base right now. So it should be interesting trying to send that data over to the Elastic server to update the database indexes. So I'm just going to check the comments real quick. Oh, nothing there. Sweet. Okay, so going back into, oh shoot, so C-Line just did an update to 2018.2, so I forgot to get that going before I started here. Let's see. Uh-oh. Nope. Don't want that one to open. Click close. Oh, they really changed it up here. Okay, so so I did a lot of refactoring over the weekend, so I'm pretty much tonight is just going to be me going over that and some design decisions that I recently made regarding the bot. Probably the biggest thing that I did is I worked on the lexing C file, or my lexer C file. So I'm just going to open up that real quick right here, and I refactored pretty much all of the code out. I got rid of the actual parsing, and I just kind of kept it strictly to what this is supposed to do, and that is tokenize or grab tokens at every so often. Probably the biggest thing is I'm checking for actual characters now. So I kind of like the other user. I think it wasn't BidSlime. It was this other guy, Style. Oh, I don't know. He comments on here sometimes. He recommended that I go look at his interpreter in Go, his Lexer in Go. So I did, and it's nice to know that I was kind of on a similar path, but not entirely. So really, all I did was I kind of refactored this whole get token to actually just handle line endings. So I kind of way earlier on in other videos I made the mention that I was just going to keep it like EOL and not even use the token EOF or even use the token EOL for that matter. But I decided to go ahead and use it. So whenever we get the next token, we know if it's end of line or if it's actually end of file. So my parser is actually going to handle that now. I've greatly reduced the function from doing anything else other than checking for specific items, and then if the values match, go ahead and create characters or store the character into the token value, advance the lexer, and return the next token. So really, this is just going to be used in some sort of like loop still to grab all my specific tokens. But I've kind of broken it up to grab specifically tokens. This no PCRL, FCL, whatever, I don't even know from the spec. Getting a letter, specific character at one at a time. Getting a space. Getting an integer. So I actually did parse out the actual integer. So if it comes across a digit, it's going to try to go ahead and create a number from that. I'm not entirely sure how well this will work, considering that this nos, whatever this is, kind of lends itself to return integer values. So I might actually like not use this code any further here, but I just have it in here just for now anyway. So the parseInt is going to take in the lexer. It's going to increment until it runs out of digits, and then it's going to try to create a token integer from that. It doesn't handle negative values, but that's okay. I think the only reason why I need the integer part anyway is for, as per the spec, commands can either be 3-digit codes or they can be strings. So no real need for to handle negatives or floating points or anything of that nature. Then I added this lexer peak next token. I'm going to use this as in the parser, but essentially all I'm doing here is I'm getting the current state, assigning to a variable, the current state of the parser, assigning it to its respective variables, and then I'm going to call the get next token, and then I'm going to return that token and then reset the state. So this way, my lexer can look ahead a token and then try to reset it. I have some comments here to note that there is an issue with this, but I'm probably not going to focus on that except for on my own time. And then, as I mentioned before, I have all these various helper functions down below defined to actually do the lexing. This is an interesting error that keeps popping up. For anyone who's watching, feel free on YouTube or here to comment on why you might think this is always returning false, this specific line. I don't understand how it would. I think it's because, well, not even up above, like all these, the way this works is that all of these on the left-hand side, all these numbers, hex values, are all lower than each other. So they kind of go in order. And then same for the right side, they also go in order. So I'm not entirely sure how this is always false when clearly a character could be in between this number and this number. So I'm pretty sure I made a mistake somewhere. But if anyone can point that out and figure it out, I'm more than happy to accept a pull request even on Git or just in the comments. That'd be great. I sure can't think of why this is always false. So that's that. Moving on. Yeah, just basic character comparisons, and then yeah. So that's it. That's all I got for the lexer now. Is that I'm literally just returning these tokens now. If it's colon, if it's end of file, or if it's end of line, a letter, space, integer, literal, or none. That's all I care about right now. So I'm just going to keep it simple and keep it like that. So that brings us to the next piece, is the actual parsing. So one of the things I focused on too over the weekend was kind of refactoring up this whole main function here. I basically just moved a whole lot of variables around for the most part. Did assignments a little bit closer to where they're being used, but the biggest takeaway here is that down below, I've greatly reduced, or I've abstracted out the functionality that was here prior. Instead of handling tokens here now, I'm actually going to have the parser actually do some real parsing and actually return me something. I'll get into that in a minute, but essentially what I did was I kind of abstracted out the information or the things that were happening already, and then put it a part of the message parser. So this message parser is what's going to be actually handling the actual tokenization, or not handling the tokenization per se, but is actually going to use the lexer and actually produce something more meaningful. Which brings us to the next piece, what this actually returns, this IRC message parser parse. I've broken that out into its own. Well, let's look at the header real quick. So, yeah, so it's going to return an IRC message. Now, I'm a fan of doing the anonymous struct definitions beforehand. There's actually a technical term for it, but it's at the tip of my tongue. Forward declarations, I think. I'm a fan of this style. I know that some people are not. So if anyone has any comments as to a different sort of style that I should be looking into instead for structuring my C applications, I'm more than happy to take suggestions to that, because I personally don't like to include extraneous header files all over the place in a header file. I feel like that adds too much dependencies when all really this header needs is just these actual structs, and it's going to do something with them. So, and then I use my C files to actually do the actual including of what I actually need to make this file work when it's all compiled in. But anyway, that was just a side note. I'm open up to suggestions if this is a horrible design. I just happen to prefer it. There's a compile time benefit to it, but this application is so small it doesn't really matter, I suppose. Anyway, so let's look at the iMessage parser in a little bit more detail. So I just have some basic functions. I allocate, I deallocate. I have that can parse function here, so that's a part of the loop in the main function there. And then the IRC message parser parse, which is going to return an IRC message. Before I get into that, just looking at some of the details here that I've implemented. So the allocation is pretty straightforward, I feel. So I'm not going to talk a little bit about that, or the destruction. One interesting to note here is that I'm actually going to deallocate the lexer here, since I have it as a dependency for my parser up here. So I'm going to make this class, and you can't see me, but I'm doing air quotes, handle the deallocation of the lexer, so I don't have to worry about that myself. This is pretty basic here. I'm just checking to make sure that the token type is EOF or not EOF, and if that's the case, then it can parse. I kind of program myself into a hole with this one. I don't exactly like what I did here per se, but it'll do for now. It'd be great for a refactor video for sure. But the important bit, so this function is meant to be ran in a loop. So I'm going to deallocate the current token that's already established. So if this never runs, if this only runs once, it's only going to deallocate that token. Then it's going to grab the next token from our lexer, set the current token, so it's a property of my hidden struct here, and then I'm just going to do things with it. So this is the functionality I just copied and pasted out of the main function of my application, just kind of pasted in here for testing purposes. And just to show how this works, it actually works quite well. So same output as before, except without spaces, but everything should be A-OK, line by line. So it looks like the output is A-OK, so I'm just going to close it now, because why not? So all I really do is just abstract that out and put it in here, so the main function is a little bit cleaner. But now to the fun bit. So this is probably like the 5th time I've said this, but since we're returning a struct IRC message, I went ahead and created my own message header here. Oh, that's not good. I should probably fix that. It's an unstd oh boy. Trying to fix that size t issue. I guess autocomplete doesn't work now. Like I said, I just updated this. Oh, here we go. Is this it? Will that do it? Sure, good enough. I just wanted to make the size t's work. So here I created an IRC message. So my message is kind of broken up into different parts. Here's where it's actually defined. It's going to have a prefix and a command. So just to keep things simple, I kind of broke it up in this way, and this is how it is anyway. On when we actually look at that output text, I don't think I have it up here anymore. Yeah, so we have the prefix, which is here, and then we have the command, and then we have the parameters that are part of that. So that's how I broke this up. These are going this IRC message is going to point to two structs. One for prefix. So prefix is nothing more than a length and a string pointer. The reason why I did that is instead of just doing char, pointer, string is because I don't want to have I don't want to personally have to call the length each time. I just want it to be part of the struct here. I could probably break that out in another session to be another sort of struct that kind of just contains this information for me, so I can use it elsewhere as a type. But that's that. I'm doing the same thing here with the command parameter. So command parameters are always strings. I kind of just left it as that too. So each parameter is going to have a string with a length. A command type. So I kind of broke this up into two pieces. So commands can either be of type code or they can be of type name. I chose to do of type. All right. So that's what this represents right here, the IRC command type. And then to wrap it all up, the command is going to be a union of whether it's the command code or the name. I probably should have the length somewhere in here in regards to the name. In fact, why don't I go ahead and do that? So I'll make a struct of name, and then size t, length, and then char pointer name. So so when this all reads out, it'll be name.name. That's fine. Command.name.name. Sure, why not? And then have the length there. And then I'll know whether it's a code or a name for this union based off the type for this enum, which is right there. And then I'm going to include some sort of unsigned int32 value to represent the parameter count. And then the command parameter, so an array of pointers to IRC command parameters, which according to the spec is 15. I also created this little IRC spec H file to contain spec-specific information. So that's kind of how I've been. So in a nutshell, this is how I broke out my entire application. I'm going to go check comments real quick. Let's see what we got. No comments. Sweet. So, so now I'm going to dive into what I want to do tonight. So I didn't want to again bore anyone with doing the parsing, but that's kind of where I'm at right now with all of this. But I might switch it up just slightly. Instead of focusing on parsing, I think I might do instead is work on how I want to handle these IRC messages, because I feel like that's going to be a little bit more fun to do tonight than to deal with looping over tokens, making sure that they return right, yada yada yada. So I went about this a couple of ways. Originally in my IRC parser, and we can look at the header file here, I created two function pointer types: IRC prefix handler _t, IRC command handler _t. So the original idea is that I could have some sort of function here that I can bind function pointers to. So whenever it reaches a command or a prefix, go ahead and execute some arbitrary array size of these function pointer handlers and kind of just run them down in a chain fashion. So it'll just run one function after another. So excuse me, I need to take some water real quick. Sorry about that. So the reasoning behind that was to allow it so that I can add some functionality into this application and probably create some sort of, or somebody mentioned a long time ago in a video, hey, you should make this into a library. Well, this is one of the ways that I might go about doing that, is by providing some sort of interface to bind functionality to it. So that was my idea, was that I had some sort of function here that would accept some user data and a pointer to one of these handlers, and it would just work. Well, the problem with that plan was that I would have to pass in specific user data if I wanted to within like this main function here, and then also I could only call these, or call the function that I had, which I no longer have here right now, so just bear with me. I would also have to call like this function, multiple times here. So I would do func, and then pass in my func pointer, and then maybe my user data, whatever that would be, right? And then it would be parser register func or something, right? So I would have to call that multiple times, and then pass in the user data once. So this is the part that kind of threw me off a little bit, is that I didn't like how this information was being passed in. Just trying to think of like how I would use this in this sort of library context. What I would like to do is maybe, if this is in a looping context, maybe I would like to pass in data multiple times, or I have to have it this way and only pass it in once. But then you have to think, well, should the parser be responsible for actually invoking these function calls and then like kind of looping through them after it's gone through a command? And I thought, well, probably not. Probably something else should be handling that. And the main reason why I didn't like this approach here, doing it only once, is because then if I'm kind of married to whatever I define outside of, or I'm kind of married to whatever I have in this thread or whatever. I would have to like create some sort of struct that I like to pass data into, similar to how how threads work here, with the thread args. But they're doing it as they create a thread. But I wanted something a little bit more fancy than that. Then I thought about passing in the user data as part of allocating the parser. Well, the problem with that is that you're making the assumption that the data that you want to pass in already exists by the time you're allocating that parser. And I was like, well, that's lame. Then I thought about creating another function to pass it in later. And once again, I was like, well, again, that's kind of lame. Because ideally what I wanted to do is every single time I passed in, or every single time I created one of these function pointers, I would like to pass in whatever data I want into it to enact on it. Now I don't know if C supports lambda functions, so I should probably actually Google that real quick, because that might actually be the answer to my problem. So C lambda Wow, that is not. Wonder if it supports it. I know C++ does it, but this is not C++. That is definitely C sharp. No, never mind. It looks like C sharp from the. No, yeah, this is C sharp. I don't care for that. And C, it would be illegal. Yeah, because it's not in scope. So the problem is to pass functionality into the scope. Here they have that function pointer that will take in that user data, so that's fine. So, yeah. So this kind of just confirmed my theory real quick that I can't really do some neat things with lambda and scope. I kind of have to pass that in. So we're back to my dilemma. So anyway, my reasoning for not doing any of those methods was simply because I didn't like how the user data would be passed into it. So instead, I have to come up with another idea of how I want to do that. And I have given it no thought today whatsoever. So with that said, I'm just going to look through some of my code to see if I can get any ideas. I definitely don't want it to be a part of the actual message parsing interface. So what I ought to do is that whenever I get some sort of command back from here, I think I might want to actually I call it IRC message. I think what I would want to do is take that and then see if I'm including it up top. Yeah. Message parser includes, no, I'm not, so I need to do this, include IRC message. There we go. Let's go down that far. So I want to get the message back from it, and then here is where I'm going to pass it to some sort of function. I kind of want to keep this. Well, I don't know. I don't know if I'm thinking of this in terms of library, or not library, I should say. It should be pretty easy for me to define some function pointers up here and call it a day. Create those functions and then somehow link them all together. So I might just do that, as a matter of fact. So I think I'm going to go ahead and create a type def. I'm just going to copy and paste from here because it's a little bit easier. I don't think I want to introduce any API functionality for handling this, honestly. At least not yet. I think what I would like to do in the future probably is set it up such that I can chain function calls whenever a message gets passed in, but I'm just going to do that explicitly. So, I mean, I guess I don't really need a function pointer then if I'm just going to do that. I might as well just have something that I can just pass in, oh, here's the message, do whatever. Shoot. Again, the problem with chaining is passing in. So maybe what I would do is I would have some sort of API that would send message and then pass in the message and then some user data. But I would need some sort of struct, so message handler. So it might look like something like that. And then here, I could do message bind handler, and then I can pass in message handler struct, and then the function pointer, and then call it a day. Screw it. I'll just create this functionality. So this is the benefit of going to a talk about message passing and techniques to do that, because message handling is or event handling or message passing is a pretty common technique, at least in the business world, to handle complicated things. But I'm going to keep this as simple as possible and just call it basic message handler. My naming says it all. I need to go ahead and fix my CMake real quick because it's going to try to add that header file in there that I don't necessarily want. Reload the changes, and then that should do it. Let's compile, make sure it builds. Perfect. And then now I have my basic message handler. Okay, so So usually I want to program my IDE. I like to have both the C file and the H file separate. Oops, excuse me. Oh, did it not create the C file for it? I could have sworn it did. If it did, I'm not seeing it. I love live debugging. Okay, well, I will just add it in here manually. I think it only created that H file for me for some reason. I don't know why. This is going to fail to even do the CMake, but that's fine. Did I do this wrong? Maybe. Oh shoot, I could have just left it. Oh jeez. I am just not into it tonight with the typing. Alright, let's go ahead and do this then. Get myself in a comfortable position here. What I call it, basic message handler, create no header file for it, add it to target, and that should do it. Include basic message handler H, and that should do it. Compile, make sure everything's hunky-dory, sweet, and we're good. Alright, let's close that so we get more viewing area. Close that. Alright, so let's define my API. So what I know for sure what I would like is some sort of send message, so I'll just do void, or yeah, I'll just do void send message. Okay, I'm going to try to keep this as ill-defined as possible with void pointers, because this is just some sort of API thing I just want to add in. So what I call this basic message handler. Do a for declare there. This will take a struct of basic message handler, and then we're going to do a void pointer of data. Okay, that should be pretty easy. Then we're going to do a void of bind, or I need to change the names of these real quick. Basic message handler send message, and this one is just going to be named bind instead. Bind handler. Of course, I need to allocate this system here. It's not thread safe. I don't intend to make it thread safe for now, so this needs to be struct. Now, this is the downside of doing things this way. I don't like users to create objects on the fly. I prefer to have control over that. So basic message handler. And before I go further, I'm going to check the Twitch feed. No comments. All right. And then I'm going to do a void of allocate the basic message handler. And it's going to be passed in a pointer of struct basic. Be nice if I had autocomplete message handler pointer, handler. So that's pretty basic. So I'm going to go ahead and oh, right, I forgot to add the function pointer, so type, so I'm going to need to do that. This is probably one of the rare cases I would do a type def, just because it does greatly simplify the API. So, and that's going to take a void pointer of data, of whatever you want. So whenever we send the message, we're going to pass in the data, and then this is going to take that data. It's going to be passed. It's going to be called with this function. It's going to take it and then do something with it. So let's go ahead and add that here. So this is going to be a pointer. So not basic message handler t. All right, do a pointer of that. Pass that in as a pointer. Handler void data. We have a bit of an issue here. Oh, naming issue. We'll just call this func handler, or yeah, wait, yeah, func handler. Func handler. I'm going to go ahead and do this sort of deal. So the cool thing about this code, or this editor, is I can do commands to reformat it, but I guess that's not working. Right here, let's see, maybe they changed the key binding. Code, reformat code, what is that? Command Shift L, so I'm kind of screwing it up. Oh, so, okay, yeah, Command Shift L, that's what I was not doing. So I'm going to save that, tidy it up a bit, and then, all right, let's move on. So, well, I think I'm missing something here. It would be nice in the future to extend this functionality to base it off of type, so I can add messages of some arbitrary type and then it'll route that to whatever handlers are listening to that. In this publisher and subscriber model that I have going on here, but I'm going to keep it simple, so I'm going to ignore that. And then real quickly, I'm going to include the unstd library here, and I'm going to pass in a size t of max handlers. So the underlying data structure for this is going to not be a linked list of sorts, nor is it going to be a dynamically resizable array. So I'm going to keep it basic, as the name suggests, and just pass in this max handlers, and that should be a-okay. So let's go ahead and copy and paste all of this over to the file here. Get rid of the type def because that's no longer needed, and then go ahead and add brackets all over the place because that's an important step. Go ahead and do that. Sweet. So here we're going to go ahead and create a struct of size t. It's going to contain max handlers, and this will be the array of the function pointer. So this will be basic message handler of type t, pointer, handlers, array of, we're going to actually allocate this, so that's okay. So let's go ahead and do that. So struct of type basic message handler pointer handler, and then we're going to do my favorite style here, double parens, not equal to null, and then we're going to do handler equals paren struct of type basic message handler pointer, malloc that to, and I need to include that, so I'm going to go ahead and include stdlib, which is there. and then I'm going to go ahead and do size of the struct basic message handler. And if that not equal to null, go ahead, well, if that equal to null, my bad. If that equal to null, go ahead and return null. Otherwise, we're going to return handler. Now we're going to actually do some allocation here. So handler max handlers equals max handlers. And then I'm going to do another malloc. So I'm going to do handlers equal a type of function pointer, so basic of type T pointer. Yeah, I'm going to do a pointer to the function pointers and do a malloc size of the basic handler function times the max handlers. And I'm going to go ahead and create an internal loop counter here. So I'm going to do size t of handler count. And then I'm going to go ahead and, well, okay, so if this returns null, then I want to, if handlers, so I want to make sure I allocate the right amount, but if I can't, I actually want to handle this situation. I don't want to throw an exception. I actually listened to a talk last night. Well, first of all, you can't throw exceptions to C, but I could do other things. But anyway, I listened to a talk last night, yesterday, from John. Oh, I can't think of his last name, but he's kind of a well-known person, programmer person, and he was talking about how he can't stand defensive programming. In fact, he created the TCL, or he calls it Tickle, language, and he said his greatest mistake was writing his unset function, which would return, or which would throw an exception if the variable that you're unsetting doesn't exist. And he said that was the worst API decision of my life, because sometimes people just want to clean up their code. Otherwise, they would have to write try and then unset multiple times for whatever they're doing, right, and then try to catch it if it ever broke. And he's like, that's the worst mistake I ever made. And then he said I was too foolish to, or I was too naive to not update that, because I thought that I would break a whole bunch of API out there. So he was like, I have to leave it. So I agree with him. I would rather just fail silently and then have it be handled that way. So I'm going to return null. And in the meantime, I'm going to free up that handler, because that needs to be killed. Return null, and then there we go. And then what I'm going to do here is handler. Actually, I'm going to go ahead and define this later, so that way we're not doing it there. And then I'm going to handler count. It's going to set that to 0, equals 0, and then handler. That's it, actually. Then we're just going to return it. And then for deallocating, it should be as trivial as doing free. We're going to free the handler handlers first, okay, and then I'm going to free the handler itself for the deallocation, and that's that. Pretty simple API to keep track of our handlers. So let's actually do that registration process now. So I'm going to have a handler. Handlers, handler count plus. So we're going to start it off at 0, but we're going to automatically increment it after the fact. So sorry, I'm going to do that last. But for now, I'm going to do the handlers at subsection 0. So handler count, and then that's going to equal the func handler. I wonder why it doesn't like that. Incompatible pointer types. Do I need to dereference that? I shouldn't. Oh, wait. Type assigning to basic message handler T from pointer, but I want to do that. Do I need a double pointer? Pretty sure I don't need that. Well, that didn't even fix it anyway. I wonder why it's trying to get me to dereference that. That doesn't seem right. Check comments real quick. Nothing. Sweet. Okay. Oops. Go back here. Handlers handler count equals incompatible pointer types. Well, I don't want to do a copy. That's for damn sure. Oh, I know where I went wrong. Okay, see where I went wrong? First of all, I'm trying to do a pointer to pointers. So really all I did was I created that array, but I forgot that I was trying to make an array of pointers, so I need a double pointer there. My mistake. Now we're all good. Tricky business doing arrays with dynamic memory, so tricky business. Same thing here. Now I need to figure out why this is going bad. Maybe the issue is that I don't think I need a double pointer there, but maybe. We'll see where that goes. I'll do a quick test to make sure that that works a-okay, but this is probably correct. The IDE static analysis isn't the worst in the world, but it is for that one thing in the main function there, or that one function I have in the Lexer. But other than that, it's actually pretty good. And then what I'm going to do is so I'm passing data into it. I wonder why I'm doing that. That don't make sense. I don't know why I have that in there. So I'm going to remove that because I don't want to pass in data as I do the binding. That doesn't make sense. But what I am going to do here now is now I'm going to loop through all of my message handlers. So for I need to make sure I keep the size t I equals 0 because I'm doing a comparison on that. I less than handler count, so we're only doing the ones, so we're not looping through the entire array. If someone's like, oh, I want 1,000,000 of these things, and then I time or I plus plus, and then we're going to do if ooh, you know what I need to do here? Real quick, I need to do an assert. Now, asserts only work for debug mode, so that's okay if I add them in here, I feel like. So I'm going to assert that func handler is not equal to null. So this should help out with debugging, as a matter of fact. But in production code, it will not be around, so beware of that. Because I want to fail silently. Again, here I might want to do the actual assert. Well, no, I can't do an assert here. Actually, I can. I can cheat it. Handlers not equal to null. So that way I'm alerted that there was an actual issue trying to allocate that memory while in debugging. Again, we're dealing with like user input, so we should try to sanitize. But I don't do it in other places, but here I'm going to be careful. Anyway, moving on. So I'm going to do another assert, once again, that the handlers at position I is not equal to null. And then what I'm going to do is I'm going to call that function. So handlers I, pass in the data, and done. Except for an error. What's the error? Do I need to dereference it? I probably need to dereference it. No? Okay. Dang it. It's not a function or a point or a function pointer. Well, I'm doing a dereference, aren't I? Oh. There's the dereference that was missing. So take the pointer, dereference it, pass in the data, and it should invoke, and we should be good to go. So we're going to register handlers, and then this is going to fire them off. This should all work. A-OK, so I'm going to go ahead and include that. Basic message handler. Go ahead and compile, make sure it all compiles. It does. Sweet. And I'm going to go ahead and create some test function up here, just for the hell of it. Void test, void pointer test. We're going to do a printf. Found and called. We're going to do a /n on that. And then down here, I'm going to do the. I'm going to clean this up later, but I just want to test it out here. Basic. I am surprised I still do not get that auto completion. Ugh, this IDE, they need to fix it for types or for this sort of construct. If it was like of type T, if I type depth everything, it would work. Surprisingly so, but here it does not. So I'm just going to call it that. Allocate basic message handler. We're going to do 10 of them, sure. Oh, this needs to be a pointer. And then I need to do, we're going to register that, so handler, basic message handler, find handler. So we're going to pass in the handler, and then we're going to do a reference to my test function, which is above, and that ought to do it. Oh, we have a problem. Incompatible types passing void pointer. Where did I go wrong? That's where I went wrong, maybe, I think. No. Did I have that right? As you can tell, I am not the best with function pointers. Void pointer. Maybe I don't need this pointer here. Because it already is a function pointer? Is that what it's saying? Yeah. Oh man, did I do this all wrong? I sure did it all wrong. Let's see here. Okay, so I naively thought, okay, I had it right all along. So we're going to do a pointer, which this is going to be our array. Okay, now we're good. This I don't think I need anymore. And I sure don't. Sweet. Now let's build it. Built just fine. Okay. And then I'm going to, just for the pure heck of it, I'm going to call that basic handler send message, the handler, and then I'm going to pass in null. And that should work a-okay. And it did not. Something broke. So let's go ahead and debug that. Where did the bad access happen? Handler's null. Interesting. Did it not allocate it? Size of struct basic message handler. That's equal to null, then go ahead and return null. Otherwise, return null here. I wonder if it hit the assert. Well, it should have hit the assert if something broke. Let's go ahead and throw in a breakpoint. Let's see if we even get that far. We do get that far. Okay. So we do have our handler. Oh, I see. Oh, see my mistake? I wasn't explicit. This should be equals to null. Not equal to null. I mean, equal to null. If that is equal to null. Assert that it's not equal to null, so this should return false and let us know that there's an issue. Well, nah, I'm just going to screw it. Yeah, no, I want there to be an issue. Can I pass in a string into these? I bet I can. Func file line, oh boy. Oh boy. Now we're getting into dangerous territory. Time for a little API viewing. C assert Geeks for Geeks, one of my favorites. Assert doesn't take anything, not even a string. Okay, I'm cool with that. So we'll just make sure that it fails. So let's run it again, and yep, there we go. And it's being called quite a bit. So there we go. All right, we're an hour in. This is where I usually kind of stop. I said I was going to push up my code. I will do that. I promise. This weekend. But we'll make it through tomorrow and Friday around this time for about an hour each, and then I'll push up the code, and then everyone can enjoy it. But this is the very simple way to implement message or event handlers in C. So that's that. I'm gonna go poke on the comments for the stream, which there are none. So that's it. Thanks for watching once again. Everything will go up on YouTube. My YouTube handle, if it can be called that, can be found here on social, and it should contain some sort of uploads, definitely. But the main thing to pay attention to is this playlist here, which contains the entire series for this. So I'm going to try to get on Twitter. People like Twitter, so I might try to get on that. But until then, that's all I got for social media. So thanks again. Thanks for watching. Hope to see you next time.